everyone, this is Sukesh Kulkarni and you are watching Cosmic Science. In nature, there are many laws which govern or on which other objects carry out their processes. Uh, Similarly, many scientists have observed these laws and they have experimented it and analyzed it. So, one of the law based on the motion of the object we are going to learn here today. That is laws of motion. A object which changes its position based on time is said to be in motion. So we are going to study this object which is in motion. So many scientists observed this motion of this particular object. There are many object planets. It may be many familiar objects on Earth. Uh, they observed it and they came to a conclusion called law. Law is a statement which is based on observation, experiment, and analysis. So, a well-known scientist, Sir Isaac Newton, he's from London. He is famous for astronomy, physicist, and polymath. So he gave three laws of motion. Uh, so, so we'll see these laws one by one. Let's go with first one. First law says that uh, any body which is in a body which is in a state of rest or in motion, it will continue in the same state unless and until force is applied to it. It means that a object it will be at rest if no external force is applied. And but but when you apply a force, it will start moving forward. Rest is converted to motion. In case of a body in motion, in case of body of the motion, uh, what happens when you apply a force? The motion gets stopped and it comes to rest. Suppose a, a box, it is moving on a surface. When it is moving, but when there is a friction from here, friction, it will stop its motion. So it is the force that is responsible for the state of the object. So this is what Newton's first law says. What is the significance of Newton's first law? It signifies or it implies that it defines the force as well as it reveals inertia. Inertia is nothing but a body will continue in its state of motion or rest when net external force is zero. Let's move forward for second Newton's second law. Newton's second law states that rate of change of momentum is directly proportional to the force applied, and momentum direction of the momentum will be in the direction of force applied. What does it mean? Suppose there is an object here. It is moving. So it is moving with a mass and velocity. It has mass and velocity, it is moving, so it has got some momentum. Suppose if I apply force, if I apply less force, it will move with less momentum. If I apply more force, it will move uh, uh, with higher momentum. So this is what it says: rate of change of momentum is directly proportional to force applied. How much we force you apply, to object, in that uh, uh, in that amount the momentum is going to change. So what does this signifies, what it implies, this law implies? It states, it implies that momentum gives the formula for force. How that gives, I'll derive it, just stay connected. Consider a body moving with a velocity. Consider a consider a body of mass m moving with a velocity v1, and momentum is p1. So object is moving, object of mass is moving with velocity v1, and its momentum is p1. So what happens um, if the velocity of the if this velocity changes, in turn of course the momentum is going to change. I'll tell you in a manner of equations. So p1 is initial momentum, and this is uh, final momentum. This is the initial momentum, and this is the final momentum. What happens when you apply this change in momentum can be written as d. These are the vector quantities dp, m1, v1, m2, v2. So what happens? Change in momentum. How we are going to see how change in momentum will give the formula for the force. For so I have reduced this change in momentum to this here. Now let's reduce it again. So here, change in momentum is equal to m into change in velocity. As velocity changes, uh, momentum is going to change. So here I can see that. So this is the formula. Now let's take definition or a mathematical form of a second law of Newton's second law. Rate of change of momentum is directly proportional to force. So we'll reduce this. We'll remove the proportionality constant. So I'll write this equation here side. So we just take this in the left hand side. We just take this term on the left hand side. Now for k is equal to 1, what happens? F is equal to dp by dt. F is equal to dp by dt. So what is dp here? What is dp? What is dp? M into change in the velocity. We'll substitute this equation here. We get F is equal to, what is dp? M into dv. We can take this as a dv, change in velocity, upon dt. F is equal to m common. What is dv by dt? dv by dt is nothing but acceleration. So this is the formula. So our intention is satisfied by statement rate of change of momentum is directly proportional to force applied, and it is in direction of force. And significance is that it gives the rate of change of momentum gives uh, the formula for the force, and it has been given here. So our second law of motion, Newton's second law of motion, is satisfied, and it has been proved. So let's move forward to the Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction. What does it mean? If I throw a ball on a wall, it comes back to me with the same force. Or it is when suppose I'm swimming in the swimming pool, and if I push the water behind me, so water is going behind me, but I am moving forward. So this is action is in this direction, and reaction is in this direction. So it is an example of Newton's third law. So what does Newton's third law signifies? It states that force does not exist in a single manner, in a single way, or in a single content. Force has to exist with uh, uh, other forces or other components of the object. So this signifies the or implies the Newton's third law. This was about Newton's three laws. So I would like to introduce a new topic, a new aspect to you, that is nothing but impul- impulsive force. So what is impulsive force? A large amount of force is been acting on a body for a short period of time. Suppose I have a hammer, I have a heavy hammer, and this is an object. I'm uh, I'm taking this hammer, and I'm hitting it on with a great force, uh, and with a small, just for 2 seconds. I hit it with for 2 seconds. So large amount of force I am applying on this object for just 2 seconds. So this is what impulsive force states. So we have seen impulsive force, but what is an impulse? We have to see that impulse is product of uh, force and time. Impulse is a product of force and time. Impulse is a vector quantity, so we denote it by this arrow. It is a product of force into time. So this was about today's concepts. If you have any doubts, comment down below. If you like this, if you find it interesting, informative, please do comment, and please hit the like button. And uh, see you in the next video with new energy and new concept. See you in the next video. Goodbye.